Okay, we're going to look at cones and composite shapes. So we're going to find the volume of a cone, and then we're going to find the volume of composite shapes. Now, a composite shape is a shape that's composed of more than one shape. So that might be, for example, a cone and a hemisphere, which we'll go on to. Let's go for example 1 for the volume of a cone. Okay, so I've been given that is 5 centimetres. The volume of a cone, its formula given to you in the formula sheet is 1/3 pi r squared h. Okay, now have a look at this. Is that the radius or the diameter that I've given? Well, the diameter would stretch from one end to the other of the circular part, so that would be the diameter there. But as you can see, that's only the radius. It goes from the centre to the outer edge, as opposed to from the outer edge through the centre and to the other outer edge. That would be the diameter. So that's definitely the radius that I've been given. And I'm also told that the height of the cone is 12 centimetres. And so it's 1/3 multiplied by pi multiplied by the radius squared multiplied by the height, which is 12. Okay, so remember that there are 3 lines of working for each one, and punch that into the calculator to 1 decimal place. Okay, and that's 314.2 cubic centimetres. Okay, so when you're finding a volume, anytime you're finding a volume, you always cube the units. Okay, example 2. Okay, example 2, got another cone. This time I'm told that that length there is 12.4 centimetres and that the height of the cone is 16 centimetres. Okay, now this time you've been given the diameter. It goes from one edge through the centre to the other edge. That's definitely the diameter. So to get the radius, I would need to half that then, and the radius will be 6.2 centimetres. Once I've established that, it's straight to the formula 1/3 pi r squared h. Okay, so it's 1/3 multiplied by pi multiplied by the radius squared, 6.2 squared multiplied by the height, which is 16. Let's punch that in the calculator. And to 1 decimal place, that's 644.1 cubic centimetres. Okay, let's try an example 3. Okay, so example 3, we're now going to find the volume of the shape. Okay, so we can see that this shape is made up of a cone and a hemisphere. Okay, so let's say that the radius of the cone is 6 centimetres, and let's say that the height of the cone is 10 centimetres. Okay, so what we need to do is split the thing up into 2. So let's say that that's volume 1 and that's volume 2. Okay, so volume 1 is a hemisphere. Now remember, for a hemisphere, it's half a sphere. The volume of a sphere is 4/3 pi r cubed. So for a hemisphere, it's 2/3 pi r cubed. Okay, so that's 2/3 times pi times the radius cubed. What's the radius? Well, the radius is definitely 6 centimetres. That's the radius of the cone, and it's also the radius of the hemisphere. So it goes from the centre of the hemisphere to the edge of the hemisphere. So it's 2/3 times pi times 6 cubed. Okay, let's punch that in the calculator. And to 1 decimal place, that is 452.4 cubic centimetres. Now we're looking to find the volume of the full thing. So we've split it up into 2. We've found the volume of the hemisphere. That's done. That's 452.4 cubic centimetres. We're now going to find V2, volume 2, which, as you can see, is a cone. So I'll go back to my formula for the cone, 1/3 pi r squared h. That's 1/3 times pi times the radius squared. What's the radius? So it's the same as the radius of the hemisphere, it's 6. Squared multiplied by the height of the cone, and as you can see, the height of the cone is 10 centimetres. Okay, so let's punch all that in. 1/3 times pi times 6 squared times 10. Into one decimal place, that will be 377.0 cubic centimetres. Okay, so the volume of the conical bit is 377.0. The volume of the hemisphere is 452.4. So I'm going to say now TV, total volume, add them both together, that's 377.0 plus 452.4. Okay, it's a calculator question, but you need the calculator for that bit. So it's going to be 7 plus 2 is 9, 7 plus 5 is 12, 2 down carry 1, 3 plus 4 plus 1 is 8, 829.4 cubic centimetres, final answer. Okay, example 4. Example 4, we've got another cone and another hemisphere on top. Okay, so this time I'm going to say that the length right across here is 15 centimetres, and I'm also going to say that the height of the cone is 25 centimetres. Okay, so let's split it again into V1 and V2. Let's call that V1, V2. So V1 is the hemisphere, 2/3 pi r cubed. Okay, so 2/3 times pi times the radius cubed. Now be careful, that is the diameter. Okay, so from here to here would be the radius, from the centre to the edge would be the radius, but I've not been given that. I've been given from the edge to the centre to the other edge. That's the diameter. The diameter is 15. You need to quickly half that to get the radius. So the radius will be, you can do that in our head, 7.5 centimetres. So it's 2/3 times pi times 7.5 cubed. And let's punch that in the calculator. To one decimal place, that will be 883.6 cubic centimetres. Let's go after volume 2. That's the cone. Formula 1/3 pi r squared h. That's 1/3 times pi times the radius squared. The radius squared. So the radius is 7.5. 7.5 squared multiplied by the height, which is 25. Okay, so let's punch that in. And that will be 1,472.6 cubic centimetres. Okay, next move as before. TV total volume, let's add them together. 883.6 plus 1,472.6. 6 and 6 is 12, 2 down carry 1, 3 plus 2 plus 1 is 6, 8 and 7 is 15, 5 down carry 1, 4 and 8 and 1 is 13, 3 down carry 1, and final answer is 2,356.2 cubic centimetres. Okay, example 5. Okay, this one's just going to be a wee bit trickier, so let's have a look. Okay, so again it's the cone in the hemisphere. Okay, so I'm going to say that that distance there is 26 centimetres and that the radius is 9 centimetres. Okay, so let's go V1 and V2. Okay, so V1 is a hemisphere, 2/3 pi r cubed. 2/3 times pi times the radius cubed. So is that the diameter of the radius I've been given there? Well, it goes from the centre to the outer edge. That's definitely the radius. The radius is definitely 9 cubed. Okay, so that's 2/3 times, I've already did that line, so punch that into the calculator. 2/3 times pi times 9 cubed. And that is 1,526.8 cubic centimetres. Okay, so V2 is the cone 1/3 pi r squared h. Let's put numbers in. 1/3 times pi times the radius squared times the height, which is 26. Now see, at that point I'm just going to pause and I'm going to be careful. Now I've just put in the height is 26 there, which is not correct. Right, you might think in first inspection that the height is 26, but it's not. Okay, now the height of the shape is 26, but the shape contains both the cone and the hemisphere. So if I want to find the height of the cone only, I should only be moving between there and there. As soon as I move from bottom to top, I'm not only finding the height of the cone, so the height of the cone stops there, but I keep going to get up to 26. Now that means to get the height of the cone only, you'll need to take this bit off between here and here. Now we already know what that bit is, because we know that the radius of the cone is 9. So if it's 9 there, which it is, it's 9 there, it's 9 there, and it's 9 going up as well. So that is 9 centimetres. So what you need to do then is take that 9 off the 26 to leave you with this height here. And 9 off 26 will give me 17 centimetres. So just to go over that again, we're looking for the height of the cone, not the height of the full shape, but the height of the cone. So the height of the full shape is definitely 26, but the full shape contains the cone and then the hemisphere. So I need to find the height of the hemisphere and then subtract that from the full height to get the height of the cone. So the height of the hemisphere is just its radius. So it's 9 there, 9 there, 9 here, 9 here, and 9 up here as well. So I subtract that 9 from the full 26, gives me 17. So the height, in fact, if you've been really careful, is 17. Okay, and at that point, enter into the calculator 1/3 times pi times 9 squared times 17. And that is going to be 1442.0 cubic centimetres. Okay, I found the volume of the cone, the volume of the hemisphere, add them together, TV, total volume is 1442.0 plus 1526.8. Okay, so that's 8, line up the decimal point, 6 and 2 is 8, 2 and 4 is 6, 5 and 4 is 9, 1 and 1 is 2. Final answer, 2968.8 cubic centimetres. Okay, example 6, let's try another like that again. Okay, so this time I'm told that the length going across the way there is 9 centimetres. The height of the shape is 23.5 centimetres. I'm going to call that V1, call that V2. Okay, V1 is a hemisphere, 2/3 pi r cubed. 2/3 times pi times the radius cubed. Now be careful again, you've been given the diameter there. Okay, so it goes from the edge to the centre to the edge, that's the diameter. The radius is it just goes from the centre to the edge, that will be half of that. So I need to quickly half that 9 to give me a radius of 4.5 centimetres. So it's 2/3 times pi times 4.5 cubed. Enter into the calculator. Okay, and that is 190.9 cubic centimetres. Okay, volume 2, as we can see, volume 2 is the cone. So let's get the formula for the cone, 1/3 pi r squared h. Okay, 1/3 times pi times the radius squared. Okay, so the radius squared, we know the radius is 4.5, so that's 4.5 squared multiplied by the height of the cone. Now again, just be careful. The height of the cone is from here to here. It's not 23.5, that's the cone plus the hemisphere. So we want the cone only, which means I need to find this bit here and subtract it from 23.5, which will leave me with the height of the cone. Well, we've seen that the radius is 4.5, so from there to there's 4.5, and there's the radius again, and there's the radius again, there it is again, and there it is again, from here to here. Okay, so that height there is the radius of the cone, that's 4.5. So I need to do the 23.5, take away the 4.5 to give me 19. And that's going to be the height of the cone. How did I get it? 23.5, take away the 4.5 will leave me with the 19. So 1/3 times pi times 4.5 squared times 19, enter the calculator. and that is 402.9 cubic centimetres to one decimal place. Total volume again, 190.9 plus 402.9, line up a decimal point, 9 and 9 is 18, 8 didn't carry 1, 0 plus 2 plus 1 is 3, 9 plus 0 is 9, 1 plus 4 is 5, 593.8 cubic centimetres, final answer. Okay, so you're going to try these ones. Question 1, you've got a cone, you've been given the radius. Question 2, you've got a cone again, but you've been given that. Is that the diameter of the radius? Question 3, now question 3 and 4 are actually slightly easier than question 5. Question 3, you don't need to work out the height of the cone, that's definitely just the height of the cone. Okay, so that's definitely the height of the cone, and you've been given this 5 up here as well. Question 4, just be careful, you've been given the length right across. What is that? Is that the diameter of the radius? But you don't need to worry about the cone, because that's definitely just the height of the cone. The height of the cone is definitely 20. Now be careful, question 5, the height of the cone is not 20. The height of the full shape is 20, so from bottom to top that's 20, but the cone is just from here to here, so you need to find out the height of the cone using the radius here, like the last couple of examples. Have a go.